I'm going to have to ask you to do something for me, and that doing something for me is to I've got to get this back. This class was no sweat. Goodness gracious, why won't the share come back? Okay. I don't know why Zoom. Okay, now we'll try it. All right, here we go. All right, our class went fine. The second class went fine on Thursday. The third class, I was running late and I only had a half hour for lunch. So I rushed out of here, forgot to end the screencast-o-matic. And then when I started teaching, oh, here comes somebody else. Ivan's coming in. So let me get him here. Ivan is here. Good deal. Okay. So I rushed back up, started class, and somewhere in the class I thought, have I started recording? And I looked down, saw my little icon there, said, yep, it's recording. Well, at the end of class, when I went to end the recording, I saw it went for 5 hours and some odd time. What I had done, I'd forgot to end the recording for my third class, and then I ate lunch, so there was a 30-minute gap there while I was eating, and then I just kept recording during that time and kept recording when I started the next class. So I wound up with 2 classes on one 5-hour recording, 5-hour plus recording. So I had to post both of those in there. I've got to tell the classes a day. The first class, just listen to the first part. I know it's got the wrong name and everything, but listen to the first part. When the class ends, stop it, okay? And then the second class, I'll say skip over about an hour and a half and then start listening there, and that's where you'll find this class recording. So if you can, at the end of the class today, please remind me, turn off the recording, stop the recording, save it as this class. So that's one thing. Now, another thing, I guess y'all noticed, or maybe you did, I don't know, that the announcement, the invite, was awfully late today. And the reason is that yesterday morning we got a text message, or no, voicemail from the dean saying, by the way, contracts are due by 10 o'clock tomorrow. Well, I only had yesterday to work on them because I'm in class from now until 10 o'clock, except for a 15-minute break. So I had to get them done yesterday. Well, they didn't have any of the material, brand new system and all like this. This is a sad, sad song. You can hear the violin in the background. So as soon as I got out of my last class yesterday, I went right into contracts, and I forgot to put the invites out yesterday afternoon. So that's why they were late coming in. I just got them done this morning when I went to check on something. I said, where's the invite? I said, oh no. So anyway. All right. Any other issues, concerns, problems? That was my sad story. Okay. This is where we left off last time. We're in Chapter 1, Functions and Their Graphs, Section 1.4, Functions, page 37, near the bottom of the page, and this is where we pick up. When using an equation to represent a function, that's something that has an equal sign in it. That's what makes an equation an equation. It is convenient to name the function for easy reference. Okay? Now, if you may have noticed, mathematicians tend to be a bit lazy. So here, for example, you know that the equation y is equal to 1 minus x squared. I think we saw that earlier as one of our examples. That's an equation. Something on this side, something on that side, equal sign in between. That makes it an equation. Now, that y this equation describes y as a function of x. You take x, square it, subtract it from 1, that gives you your y. That's the meat grinder that you got, the sausage grinder. Okay? Whatever you put in, x, you square it, subtract that from 1, and that spits out your y. Okay? That's the function. Suppose we give this function the name. Now what could we call a function? Maybe f, okay, for function. Then you can use the following function notation. If your input is x, the output is going to be f of x, okay? And f of x is equal to 1 minus x squared. Now, I tell my Math 112 classes this just about every time I teach it. If there's one thing you remember in this course about functions, remember this. Y is equal to f of x. If you remember that, you've got most of functions down. Maybe not everything, but the big part of it. Remember that. Y is equal to f of x. Okay? It's going to show up on a slide, but while it's here, notice here we say y is this, down here we said f of x is this. Same. It's the same thing. Okay? So, any questions? I can't advance until I click on the screen again. All right. The symbol f of x is read, if you read it this way, the value of f at x. That's one way to read it, or simply f of x. That's how I always read it, f of x. The symbol f of x corresponds to the y value. That's exactly what I said before. So you can write this. Note this. Y is equal to f of x. The most important thing in the course about functions, y is your f of x. Keep in mind that f is the name of the function, whereas f of x is the value of the function at the value x. So x is the input, f of x is the output. That's the value of the function when you use this input. For instance, here's another f of x, 3 minus 2x. What happens if you put f of minus 1? Well, where you see an x here, you see it was f of x, now it's f of minus 1. So everywhere you see an x up here, put a minus 1 in its place. So I'm going to pull out my handy dandy little pad here and just continue this a step here and say this implies that f of minus 1, that's what they're saying here, is equal to 3 minus 2, and everywhere you saw an x here, you put a minus 1 in its place, times minus 1. Okay, and what would that be? 3, and what's minus 2 times minus 1? Anybody? Are you with me? I've already put you to sleep.
It will be plus 2.
Plus 2. Excellent. And 3 plus 2 is? 5. There we have it. Look at that. F of minus 1 is 5. F of x is an unknown value, 3 minus 2x, but f of minus 1, you know what to put in for the x now. Let's do the next one. F of 0, one of my favorites of all time. What would that be? 3 minus 2 times 0. 2 times 0? That'll be 3. Excellent. Okay. Let's do f of 2. F of 2. That would be 3 minus 2 times 2. What would that be?
7. No, I'm sorry. Yeah, 7.
Okay. 3 minus, what's 2 times 2? 4. 3 minus 4 is? Your dog had the right answer. Okay. What's that? Negative 1. Perfect. Perfect. Okay. Right. So to find those values, all you do is put in the value where you saw the x, because the value went in where the x was here, so put in the value here too. There you have it. Oh, here comes Ladarius. Let me get him on the roll. Hold on a moment. If I can find Ladarius now. I hear him coming in. He's making, oh no, that's my echo. That's not him. There's Ladarius. All right. So I got Ladarius here. Welcome. All right. We're on in Chapter 1, Functions of the Graph, Section 1.4, Functions, page 37. Just at the bottom of the page, we're just doing this. So remember, the f of means the value of the function at when x is minus 1, when x is 0, when x is 2, or whatever. To find these values, just plug them in, just like Glade, right? Plug them in. All right. Evidently, it's not going to let me advance, so let me go one more. Okay, here we go. Here they did it. For f of minus 1, 3 minus 2 times minus 1 is 3 plus 2 is 5. F is 0. That was my favorite. 3 minus 2 times 0 is 0. That's 3. And f of 2, plug in a 2. 3 minus 2 times 2 is minus 4. So that's 3 minus 4 is minus 1. Now, although f is used as a convenient function name and x is everybody's favorite independent variable, it can be anything, okay? You can use other letters. There's not restricted to f and not restricted to x. So this function here, f of x is equal to x squared minus 4x plus 7. Basically, that's telling you, take the x, square it, take what's inside the parentheses, square it, subtract 4 times it, and add 7. Well, guess what? This tells you the same thing. F of t would then be t squared. What's in the parentheses, square it, subtract 4 times it, and add 7. That's the same function. Even though you call the independent variable x here, you called it t here. Call it anything you want to. You could call it Stickman. That would be fine too. Okay? You could even change the name of f. Make it g. If g of s takes s, squares it, subtracts 4 times it, and adds 7, that's the same function. Just going by a different name, using a different independent variable. It doesn't matter. They're all the same function because they're all doing the same things to whatever's in the parentheses. That makes them the same function. In fact, the role of the independent variable now is just that of a placeholder. He's a dummy variable. Doesn't matter what you put there. You could put a Stickman if you wanted to, and that would work out fine. Okay, here they just put a rectangle. F of rectangle is equal to rectangle squared minus 4 rectangles plus 7. That's perfectly fine. You could put anything there you wanted to. A function is the, okay, this statement here should be on the next slide. I mean, I don't know why they put it here. Okay, it's whoever was doing the graphics kind of blew that one. Okay, because we've got a couple of one example to do before we need this statement. And they leave out the example, so let's go to our whiteboard and do the example. Now, of course, as soon as I get to the whiteboard, I've got to start maneuvering things around again. You can't see, but I have a taskbar that's down in the white space. Get that out of the way as far as possible. And then my whiteboard is limited in space. Yours takes up the whole screen, I've been told. So I'm going to scoot mine over as far as I can to the left and up as far as it'll go to give me maximum white space. Okay, there we have it. So let me get my book in lap here, my ionizing pen in hand, and let's do example 3. This, to me, is one of the most important examples we've hit so far. They left it off the PowerPoint, which is sort of a shame. Okay, here we go. Here is a g of x is equal to minus x squared plus 4x plus 1. Not quite the same one we had before, but it looks sort of similar. New function. Says find each functional value. Let's start with g of 2. Okay, you tell me what to write. Anybody? I'll get you started. Minus Anybody?
2.
2 squared plus 4 times 2 plus 1. Perfect. Now comes the first little place where people tend to trip. And I usually say minus signs are only there to make you fall down. They're there to trip you. Okay? What do we do first here? Is this negative 2 squared or is it minus 2 squared? There's a difference. Anyone know?
Negative.
That would be negative because we do the rules for order of operation. Please excuse my dear Aunt Sally. I don't know what she did, but please excuse her. Please is parentheses. You do those first. We don't have any except this around the 2, and there's nothing. Oh, wait. Here comes Shay. Got to get Shay in here. And somebody, the person I was talking about, I can't remember who it was, said he sat outside the class. I don't remember if it was this class or not. For 30 minutes looking at a screen, and it was the right screen. There you are, Shay Newell. Got her here. All right. For, he said, 15 to 20 minutes and never was admitted in the class. I said, I don't know how that happened because most of the time you get something, I don't know, y'all probably couldn't see that, but the screen popped down that somebody was waiting. So I put them in. But he claimed that he sat and waited for 30 minutes and was never admitted. I think he may have had the wrong code, but I don't know for sure. But I don't think it was this class. I don't recognize the name. All right, so whoever was answering, by the way, Shay, you just got here. We're in Chapter 1, Functions of the Graphs, Section 1.4, Functions. We're doing Example 3 on page 38 on the A part right now. We've just plugged in, and now we're evaluating. And we were saying, please excuse, so you do exponents first before you do multiplications or divisions. That's my dear Aunt Sally, or additions and subtractions. Count the negation as a subtraction. So we do the 2 first. So we do the minus 4, as someone said. What's next? Plus 8 plus 1. And what is that equal to? Y'all are quick. 5. Perfect. All right, how about this one? What if we did g of t? Whoa, what would that be? We go back to the original, not that one. And what would that be? I'll start it off with a minus. T squared plus 4t plus 1. Y'all are good. That's it. Done. Nothing else to do to that one. And here comes the tricky one. This is one reason this is so important. They should have done this on the PowerPoint. What if you had g of x plus 2? What? Can you do that? Sure. Whatever's in here, you put in there. So what do you have? I'll start it off with minus x plus 2 squared. Now I put that in parentheses so you know you do square that before you subtract here. Okay. Next, plus 4 times, again put it in parentheses, x plus 2, and then plus 1. All right, take your time, take all the steps you need, don't get in a rush. Let's leave that minus sign out here. Can you square the binomial here? Anyone know what that would be? Okay, it's going to start x squared. Okay, now if you don't know the rule for squaring a binomial, come over to the side. And what does x plus 2 squared mean? X plus 2 squared means anything that you square, you multiply by itself. So that means it's x plus 2 times x plus 2. Okay? And now how do you do that? Our good old buddy FOIL. First is x times x is x squared. Next is the outer plus 2x. And you've already ahead of me. Then we do the inner, which is another plus 2x. And then we do the last, FOIL, F-O-I-L, and that would be, the x didn't show up, plus 4. Okay, then combine like terms, you get x squared plus 4x plus 4. Now you can do that anytime you want, and you see you get a smiley face, so you're really happy with that answer, okay? But here's the easier way, and it's exactly what we did if you think about it. You square the first term, which is what we did, twice the product of the two terms. 2 times x is 2x, double that, and you get plus 4x. Well, that's exactly what we did here. A 2x plus 2x, yeah. And then square the last term, plus 4. And that's exactly what we got here. Okay? Now put that in parentheses, and now we can multiply this through to distribute the 4 through here, and what would that give you? For x plus 8 plus 1. Now use that minus sign. Finally we get around to at Sally. Okay, the last thing here is do the subtraction. Minus x squared minus 4x minus 4. Remember, minus signs are there to trip you up. Remember, you distribute that all the way through, plus 4x, and we can combine these two and make it plus 9. Okay? Now, what do we see happening? Minus x squared is the only squared term, but here we have a minus 4x and a plus 4x. They add to 0. And then they what? Well, they add to 0 is what they do. I crossed them out, but they add to 0, so there's no x term. Does that make sense? Okay, good deal. And then you got a minus 4 plus 9 is plus 5. There we've done it. There is g of x plus 2, turns out being a totally new function, minus x squared plus 5. Okay? Just take it. How do you eat a 5,000-pound elephant? Anyone know? One bite at a time. Exactly. Okay? So that's what you do on these problems. Write them down. Take a step at a time. One step at a time. Keep stepping till you get to your answer. Okay? Just make sure all your steps are right. You know, make sure you chew them properly. All right, so that was example 3. Okay? Now, after every example, what do you find? A checkpoint. And what's good about those checkpoints? Well, they're very similar to what we just did. So I'd say as soon as you can after you get out of class, if you don't have another class, try to go back and do all the checkpoints for the examples we did. Okay? And if you want to check your answer for the checkpoints, those are found somewhere in the back of the book where all the answers are found. But if you can't get that answer and you can't figure out how in the world they got that answer, then go to larsonprecalculus.com. I've showed you that before. Let me just hold it up again for anyone who wasn't here. See, there's the checkpoint. Very similar to what we just did right there. Okay, and it says audio video solutions in English and Spanish are at larsonprecalculus.com. Absolutely free website, no code, no key, nothing required. Anyone can go to that website. Okay, now let's back up a step. Any questions on this before I leave the screen? So you now know how to evaluate a function. Whatever goes in the parentheses here, replace it with what was in the parentheses there. In total. Okay. Now, let's go back to the text if I can get my pen to show up here, and we'll go back to the PowerPoint show. And remember this last sentence I said didn't belong on this slide? That happens after example 3. A function defined by 2 or more equations over a specified domain is called a piecewise defined function. Well, frankly, when I read that, it sounds like blah, blah, blah. Okay, let's see what they're talking about. Here's a function, okay? Now this function, they don't tell you its domain, but it looks like it's everywhere from negative infinity, everything less than 0, up to 0, but then down here it picks up at 0 and goes to everything beyond that. So the domain of the function is all real numbers, from negative infinity to positive infinity. However, it's defined in pieces. The piece that is when you have a negative x is this definition, and the piece for the positive x's and 0 is that definition. Now, it doesn't have to end at 0. It could be anything in there. You could have 3 or 4 of these definitions here. You just have to do them over each little bit of the domain. All right. So how will we do this? Let me pull down my tablet, and we want to evaluate the function when x equals -1. So what is f of -1? Okay, it looks like somebody left the class, but I don't think anyone else is waiting to get in. Let me just check and see. Every time that pops up, I like to check. Let me go to the top and make sure nobody is waiting. Nope, nobody's waiting. All right, minimize that again. Okay, f of -1. How do we do that? Okay, you see we're doing when x is equal to -1. Well, before you start plugging in, you find out where in the world you are, Waldo. Okay, y'all don't remember that, do you? -1. Is that less than 0 or greater than or equal to 0? X is your? It's less than 0. So we use the top formulation here. That would be -1 squared plus 1. And what is -1 squared? Anybody?
2?
No, -1 squared.
Oh.
-1 times -1 is 1. Plus 1 is, oh, you give me the answer. Okay, okay, I'm sorry. 2. Absolutely. Didn't know you'd be doing such high-level math today, did you? 1 plus 1 is 2. Okay, you got it. Now, the next one, it says find when x is equal to 0. So we're going to do f of 0. Well, how do you do that? You figure out where in the world you are, Waldo. Is 0 less than 0 or is 0 greater than or equal to 0? Which one do we use?
Equal to 0.
Yes, exactly. So we use the bottom one. So that would be 0 minus 1. And what's that equal to?
1.
No, minus 1.
Yep, negative.
Yeah, right. Okay, good deal. Okay, now, next they're asking what it happens when x is equal to 1. Well, you ask yourself, where in the world are you, Waldo? And where are you? Upper one or lower one?
Lower.
Lower. So you use this one, and that's 1 minus 1 equal
0.
0. Perfect. Y'all are good at this, okay? There is how you evaluate a piecewise defined function. First, figure out where you are in the domain. And whichever part of the domain you're in, you use that formulation to tell you what your function value is. Does that make sense? Now you might say, oh, someone just made this up to make it more difficult. Have you ever used a piecewise defined function? I bet you have. Have you ever mailed a letter? Surely you have. If that letter was less than 1 ounce, your postage was a certain amount. I don't even know what it is now. We use forever stamps, so I don't even know what the cost is. But if it's more than 1 ounce, you have to use another. And the postal thing is anything from 0 to 1 ounce is here. Everything 1 ounce to 2 ounces here, 3 ounces, yeah, it goes on up. That's a piecewise defined function. So yeah, you've used that. Some of the old telephone plans used to do this. If you use 0 to 200 minutes, you paid this much a minute. If you went 200 to 300, you paid an additional this much a minute. That's a piecewise defined function. So there's lots of them out there, and I bet you have used them sometime in your life, whether you really realized it or not. Let's see how the book did it. I'm sorry I can't erase my screen here, but let's see what we can do. Because x equal minus 1, the first one here, is less than 0, we use the top formulation, f of x is equal to x squared plus 1, to obtain f of minus 1 is equal to minus 1 squared plus 1, which of course is 2. Okay? And then for the next one, because x equals 0 is in this group, we use f of x equal x minus 1. And you put 0 minus 1, and that comes up being negative 1. Perfect. And then we'll do the same thing for the x equal 1. That's in the lower group because it's greater than 0. So we will do x equal 1. You'll plug this into the second formulation, and that's 1 minus 1, which of course is 0. All right. Any questions on that? And guess what? There's a checkpoint. So please do the checkpoints as soon as you can after class. Okay? Now, somebody else, or the rest of you, let me remind you of this too. I tend to get long-winded, so please, if I start running over, let me know. We've still got almost half an hour, so let's go. So let's move on to, they're skipping examples 5 and 6 before they move on to domain of a function. So let's go, we'll back up a slide and go to the whiteboard. And anyone need that any longer? Boy, that's ugly writing, isn't it? Don't agree with me. Okay. All right. We'll clear that off. And let's do example 5. And again, to me, this is a very new concept. Why they left this off the slideshow, I don't know. This really should have been there. Now, here's the question. For all real values of x, I'm going to spell it out this time. All x's, find, I'm sorry, I should put find. This is not writing well. Find all real values of x for which f of x is equal to 0. Goodness gracious, this pen is not writing well at all. Okay, here's the first one. Here's your f of x. F of x is equal to, this is the A one, negative 2x plus 10. Okay? Now, they want you to find the x's now. Oh, there it is. No, that's not what I mean. Find the x's which makes f of x equals 0. Well, if this is f of x, right here, guess what we do? We set it equal to 0 and then find the x. You did this way back in algebra, didn't you? Now we're just referring to it as a function. That's all it is. Okay? How would you do this? What would be your first step? Subtract 10 from both sides of the equation. Perfect. Y'all are good at this. Those go to 0. That gives you negative 2x is equal to negative 10. And then you do what?
Divide by negative 2.
Perfect. Divide by negative 2. Okay? These divide out to be 1. leaving you just 1x is equal to what?
5.
5. You got it. Now, I always like to go back and check. So let's go back and check. You put a 5 in. Negative 2 times 5 is minus 10, plus 10 is 0. Yes, we found all the x's, one and only one. Now, how do we know that it's one and only one? Look at the exponent for the x. You don't see one. That means it's a 1. So when you have a linear function, have an equation like this, one and only one answer. Okay? The next one, however, is going to be this one. F of x, different f of x now, is equal to x squared minus 5x plus 6, and we want to find all the x's for which f of x equals 0. So guess what we do? Set it equal to 0. Now we have a good old equation again. Now for a linear equation, we just start isolating the x. For a quadratic or anything higher, we actually want everything on one side, 0 on the other side. We got it already. What's our next step? Okay. Now if any of you find this offensive, I'll quit saying it. But here's what I usually ask my class. What's the F word? Now you better not say the other one. In this class, the F word is factor. Okay? Is that okay with everybody? Can we factor this? Because we want to get it to be linear equations. Let's see if we can. If it's factorable, the thing on the left will still equal 0. Now, remember how we multiplied binomials? Foiling. How we factor them, I call it unfoiling. I've never seen a book call it that, but okay. Let's first unfoil x squared. What's the only possible factorization for x squared? X times x. Perfect. Now where we go next, we don't quite spell properly. We just look at the sign of the last term. That's a plus. That means these two signs have to be the same. The only way you get a plus when you multiply is for these two to be the same sign. We'll look at the middle term to see what sign that is. That's a minus and a minus. Now, what we want now are two numbers that multiply to be 6, add to be 5. Anybody? 2 and 3. Y'all are good. Okay, let's check it. For it, x times x is x squared, minus 3x, minus 2x, that's minus 5x, plus 6. Yes, 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 that worked. Now, what do we do with that? Looks like we just made it more complicated.
Do we put equal signs to each?
Absolutely. What you have here is a product of two entities, their numbers, and the product is 0, right? That's what it's telling you. This multiplied by that equals 0. Now you tell me what two numbers can multiply together and be 0. Guess what? One of them has to be 0. Maybe both, okay? But at least one of them has to be 0, right? Any two other numbers, you come up with two numbers, neither one of them 0, that multiplied to be 0, you win a prize. I think it's called the Fields Medal. It's the highest level medal award ever given in the field of mathematics. They don't get Nobel Prizes for math. I don't think Nobel liked math. So anyway, there aren't any. It's only 0. So that's why you said either x minus 2 has to equal 0 or x minus 3 has to equal 0. That's the only way you can get them to multiply together and give your product 0. Now we got linear equations. That's easy to solve. What's that again? Okay. All right. What does this give us? The first one here? 2. X equal 2. We got that by adding 2 to both sides. And over here we get
3.
X equal 3 because we got that by adding 3 to both sides. Well, guess what? maximum exponent was 2, we came out with 2 solutions. Now we won't always get 2 solutions. Sometimes we may only get 1. Sometimes we'll have no solutions. But you can't have more than 2. So we found 2. That's the most we could have. So we found all the x's for which that f of x is equal to 0. Does that make sense? And you check in the book, the first one was x equal 5. The second one was either x equal 2 or x equal 3. Yes, they got it right. Good for them. Guess what? There's a checkpoint right after that. Okay? Ready to move to example 6? Okay. Unless someone needs this any longer, speak now or forever hold your peace. I'm going to clear the drawings. Okay? All right. Example 6. This time, we want all values of x. I usually don't write these things out. Yeah, I hate this thing. For which, okay, is someone coming back in? My thing just popped up. I don't see anybody waiting. Nope, I don't see anyone waiting. Okay, for which f of x is equal to g of x. Well, they must be going to give us 2 functions. Sure enough, they do. The first one, they say f of x is equal to x squared plus 1. Nice little function. And g of x is equal to 3x minus x squared. Okay, what in the world do we do with that? Exactly what they told us to. You take f of x, which is x squared plus 1. That was your f of x, right? And you set it equal to g of x. And g of x is 3x minus x squared. There we have it. Oh, we got to find the x's though. So how do we do that? Notice we do have an exponent greater than 1. So what we try now is get everything on one side, 0 on the other side. So we can do the F word, factor. So how would you do that? Anybody? How about adding x squared to both sides? Is that okay? Legal in most states, right? And while we're at it, let's go on and subtract 3x from both sides. Now, if you don't want to do 2 steps at once, you don't have to. I'm just lazy. It's hard for me to write, so I'm going to do it. So I'm going to also subtract 3x from both sides. Okay? Now this side, that will go to 0. This will go to 0. So our right-hand side is 0, which is exactly what we wanted. Over here, we have x squared plus x squared. That's 2x squared. And then we only have one 3x term, so it's minus 3x. And then we only have one constant, plus 1. Okay, and what do we choose to do here? What's the F word? Factor. Now I ask you, what's the only possible factorization of 2x squared? Two x times x. Perfect. Look at the last sign of the last term. It's a plus. That means these two signs have to be the same. The middle sign is minus, so we put a minus here and a minus here. And the only factorization for 1 is 1 and 1. Okay? We don't know that this works. It may not be factorable. So let's check it and see. 2x times x is 2x squared. Yes, that works. 2x times minus 1 is minus 2x minus x. Sure enough, that's minus 3x plus 1. Yes, that works. Where do we go from here? Okay, it popped up again. I don't think anyone's coming in. Nope. Okay. Next. Because you have a product of two entities equal to 0, one or the other of those has to be 0. Either 2x minus 1 is equal to 0, or x minus 1 is equal to 0. Okay? What do we do here? Add 1 to both sides, so the whole purpose here is to isolate the x. So get rid of that. That adds to 0. That gives you 2x is equal to 1. And then what do we do? Again, we're trying to isolate the x. Divide by 2. That gives us x equal 1/2. Over here, it's just simply add 1 to both sides. That adds to 0, and you get x equal 1. Two possible solutions. Oh, by the way, I forgot to check my last problem. I always like to check my problems. This one's going to be a little messier, but not bad. Let's try it over here. Let's do f of 1/2. That was our first answer here. X equal 1/2. Well, this will be 1/2 squared plus 1. Well, what's 1/2 squared? Anyone know? Anybody? What does squaring mean? Multiply it by itself. 1/2 times 1/2 is 1/4 plus. Now I'm not going to write 1. I'm going to write 1 in terms of fourths. How many fourths is 1? 4 fourths. Isn't that 1? And 1/4 plus 4 fourths is 5 fourths. Add the numerators, keep your denominator. Let's do the same thing here. Let's do g of 1/2. That's what we found our answer to be. And this will be 3 times 1/2. Now you don't have to check. I'm just checking because I'm paranoid. I don't like to make mistakes, so I make plenty of them. Okay, minus 1/2 squared. Okay, I don't have much room here, so this is going to be 3 times 1/2 is 3/2 minus, and we already did that, that's 1/4. Well, let's get that to fourths. This will be 6 fourths minus 6 fourths minus 1/4, and sure enough, that's also 5 fourths. So yep, these two are equal. That answer works. Now, that was a hard one. The x equal 1 is easy. Okay, f of 1 is equal to 1 squared plus 1. 1 squared is 1. 1 plus 1 is 2. Okay, g of 1, again, fairly easy. 3 times 1 is 3. Minus 1 squared is 1. 3 minus 1 is 2. Yes, both of them check. Maximum exponent 2. You can't get more than 2 answers. We found them both. They both work. We're happy campers, aren't we? All right. Everybody see how that works? Except I must have written the problem down wrong. They got different answers in the back. Y'all let me get away with that? Oh, no, I'm sorry. We just done the A part. We haven't done the B part. Whew. I was looking at the B part answer. X equal 1/2 and x equal 1. Those are your answers. Let's do the B part. Anyone need that up here a little longer? Or can I erase it? Speak now or forever hold your peace. Okay, I don't hear anything, so I'm going to clear it. Okay, let's do the B part. The B part said alpha of x is equal to x squared minus 1 and g of x, looks like a y, but that's a g. G of x is equal to minus x squared plus x plus 2. And what did they ask us for? Find the values of x's for which alpha of x equals g of x. So we write that down. X squared minus 1 equal minus x squared plus x plus 2. Okay? How would we proceed? Someone tell me. I put you back to sleep, didn't I? Okay. Add x squared to both sides to get all your x squareds together. They like to be together. Oops, if I could write x squared. Let's subtract x from both sides. We don't even have one over here, so we'll just subtract x. And we'll also subtract 2 from both sides. Now combine like terms here, and that gives you 2x squared minus x, and then you have minus 1 minus 2 is minus 3. And over here, this adds 0, that adds a 0, that adds a 0, so you just got 0 here. That's what we wanted. Now we see if we can factor, because we want to set those equal to 0, because that's what the right hand side is. Only possible factorization for 2x squared is 2x times x. Signs here is a negative. Uh-oh. That means one of these is plus and one minus. You want to make a guess? Doesn't matter. We'll find out if you're right or not. Let's just do plus minus and see what works. And the only possible factorization of 3 is 3 and 1, or 1 and 3. So we have a bunch of choices here. Let's go with 1 and 3 and see what happens. Let's check it. 2x times x is 2x squared. That works. 2x times minus 3 is minus 6x plus x. Doesn't work. We got the wrong number. So therefore, let's change the numbers. And since I have a magic board here, I can just erase my numbers. Okay? And I'll take the 3 off here and the 1 off here and put them in reverse order. I'll put the 3 here and the 1 there. Now we'll try it. 2x times x is still 2x squared. That works. We got 2x times 1 is minus 2x plus 3x. That would be plus x. Oh man, it's supposed to be a minus x. Well, if the sign's wrong, just change the sign. So make this the plus and make the other one the minus. So I'll go here to my magic board here and erase the plus. Okay? Now, let's check it one more time. 2x times x is 2x squared plus 2x minus 3x. That gives us minus x. Minus 3 times 1 is minus 3. That works. Finally, we got it right. Now, we have two entities multiplied together equaling 0, that one or the other of them is 0. So either 2x minus 3 is equal to 0, or x plus 1, if I could write, is equal to 0. On this one, add 3 to both sides because we're trying to solve for x. Isolate the x. Add 3 to both sides, and there you get rid of your 3's here because they add to 0. That gives you 2x is equal to 3. And now all you do is divide by, because again you're trying to isolate the x, divide by 2. And that gives you x equal 3/2. Over here, all you do is subtract 1 from both sides, and you get x is equal to minus 1. Oh boy, one of these again, don't we? Okay, let's check it. You don't have to check it, but I like to get right answers, so I like to check. F of 3 halves, that's a pretty ugly 3, isn't it? That's equal to 3 halves squared, which is 9/4. 3 halves times 3 halves is 9. 3 times 3 is 9. 2 times 2 is 4. Minus 1, but 1 is 4/4, so do minus 4/4. Hey, guess what we get? We get that good old 5/4 again. That's bizarre. Let's do this one again, and that will be a minus 3 halves squared. That would be 9/4 plus 3 halves, which is 6/4, plus 2, but 2 is 8/4. Okay, well, 6 and 8 is 14, so subtract 9, no, 6 and 8 is 14, subtract 9 from it, and you get 5/4. Bizarre, it gives you the same answer as our last one. No, that wasn't what we got. Well, I don't know, I don't remember. So that one works. Let's try the minus 1. F of minus 1 is equal to 1, because negative 1 squared is 1, minus 1 is 0. Let's see what G of minus 1 would be. Well, that's minus a minus 1 squared. Well, minus 1 squared is 1. Negate that, and you get a minus 1. And then you have another minus 1, x equal minus 1. And then add 2 to that, and sure enough, you get 0. Minus 2 plus 2 is 0. So yes, both of those work. X equal negative 3 halves and negative 1. Guess what? There's a checkpoint. Please do the checkpoints as soon as you can after class, just to say, make sure you understand it. Refresh it. Watching me do it is passive. Doing it yourself is active. So please get active with it. Get out there and do it yourself. All right, let's go back to the screen share. And you're kidding me, just when we're beginning to have fun. Oh, we were always having fun. All right. We're going to start at the top of page 40, domain of a function. Now this is taking us forever to get through 1.4, but you know, there's nothing too wrong with that, because this introduces functions. That's the name of the section. The whole course is the algebra of functions. So if you don't get this down, you're going to have trouble with the whole thing. So we'll begin with that slide there, domain of a function. But the good news is we did have, we got far enough along to do some homework exercises. So you can do either 5 or 7. They're both at Calc Chat. 7's at Calc View. Do number 9, it's at Calc Chat. Do any of the odds 11 through 17, they're all at Calc Chat. 11's at Calc View. Do any of the odds 19 to 29, they're all at Calc Chat. 21's at Calc View. Do either 31 or 33, they're both at Calc Chat. Then do any of the odds 35 to 41, they're all at Calc Chat. 37's at Calc View. Do either 43 or 45, they're both at Calc Chat, and 43's at Calc View. Stop there. That's as far as we go with what we've covered in class. So go through 45. And next time we'll finish, knock on wood, finish 1.4 and finally get into 1.5. Good deal. Any questions? Last thoughts, parting shots. Anything you want to deal with? Okay, well, I'm going to stop sharing. I'm tired of sharing. All right, and if there are no questions, we're going to end the meeting for everybody. Okay? No questions? Well, take care. We'll see you on Thursday. I'll try to have the announcement out on time. So take care. See you Thursday.